Hello, I'm Edward Tarte, math teacher. This is another in my series of solution videos to some of my math challenges. This one is to my second Pascal's triangle challenge. Here is how I presented that challenge in the original video. This challenge, like one of my earlier math challenges, is based on Pascal's triangle, a triangular array of numbers which I will now briefly go over with you in the same way that I did in the previous video. I put a 1 at the top, and at each of the positions shown here below that 1, I will put the number of ways of getting to that position following these slanted lines down from the top. For example, there's only one way of getting to this one, and that's to veer to the left every step of the way from the top down to there. To take a location at the extreme right, this one for example, there's only one way to get here, and that's to veer to the right every step of the way from here on down. In fact, I realized that I must put 1s all the way down the left-hand side, as well as all the way down the right-hand side. As for the interior numbers, there are two ways to get to this location: left then right, or right then left. Or to put it another way, the two gateways to this location are these two, the two above it. And since there's one way to get here and one way to get here, there must be two ways to get here. It follows then, concerning this location, that since there is one way to get there and two ways to get there, there are three ways to get here. So what I'm doing is adding the two numbers above to get the new number. 1 plus 2 is 3. 2 plus 1 is 3. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And so we have what I now call the top, row 1, row 2, row 3, row 4, and row 5 of Pascal's triangle, and this process continues downward indefinitely. Now, leading up to the challenge, I'm going to give you a warm-up question, and then I'll give you the challenge. The warm-up question and the challenge concern a club with a given number of members, and they want to form a committee of some of those members. Here's the warm-up question. Suppose we have a club of 5 members, and they want to form a committee of 2 members. How many ways can they do it? Well, we could actually make a list. Suppose that the club has members whom we call A, B, C, D, and E, 5 members. They could have members A and B on the committee, or A and C, and so on. You could list all possible formations of the committee. And then you can count how many possible committees are in that list. The answer is a number in Pascal's triangle. Find that number, notice exactly where it is located, and try to answer this question. Why is that answer in Pascal's triangle at that exact location? That's the warm-up. Now the challenge. A question like it, but with bigger numbers, so that it will not be feasible to make a list. Suppose it's a club of 10 members and they want to form a committee of 4 members. How many ways can they do it? The correct answer is a number somewhere in Pascal's triangle. It's further down than what you see here. Find the correct location in Pascal's triangle, determine what that number is, and explain why that answer is in Pascal's triangle at that exact location. Here's my solution. Here is Pascal's triangle down through row 5, and to the right of it I have something referring to the warm-up. You have a club of 5 members, I call them A, B, C, D, and E, and they want to form a committee of 2 of their members. In how many different ways can they do it? We can list all the ways. AB, AC, AD, AE. Having listed AB, we don't list BA also because it's the same committee, the same 2 people. But we list BC, BD, DE. In the C column, we don't list CA or CB because we've already listed those. It's the same 2 people as AC and BC. So in the C column, we just have CD and CE, and then in the D column, we have simply DE. How many ways is that to form a committee of 2 from a club of 5? 10 ways. And that number 10 appears twice in this part of Pascal's triangle. I have circled it as you see. The location of that 10 is such that there are 10 ways to get to that location, and to do it you have 5 little paths to follow from the top down, and 2 of them must veer to the right in order to get to that particular 10. That is analogous to having a club of 5 members, 2 of them being selected to be on a committee. Now to answer the main challenge. Given a club of 10 members, how many ways are there to form a committee of 4 members? To respond to that question, we need to extend Pascal's triangle to row 10. By that I mean the row that has 10 as the second number. I've done that. Row 10 is at the very bottom. The numbers in row 10 are 1, 10, 45, 120, 210, 252, 210, 120, 45, 10, and 1. Looking at these numbers on row 10 from left to right, this first number 1 is arrived at in only one way, 10 little paths, none of them veering to the right. That is analogous to having a club of 10 members and not forming any committee at all. There's one way of doing that, and that's to do nothing. To get to this 10, we have to follow 10 little paths, only one of them veering to the right. For this number 45, we've got 10 paths, 2 of them veering to the right. Here we have 3 of them veering to the right. And this number 210, to get to it, there are 210 ways. You have to follow 10 little paths, 4 of them veering to the right. And so this 210 is the answer to the challenge. It is analogous to having a club of 10 members, 4 of whom will be on a committee. And so that is my solution to my second Pascal's triangle video. Thank you for watching this solution video.